participate. So we'll begin. We will just continue our discussion we had last time. So last meeting, I introduced the names of ions, the cations and anions. So let's recall a few important information in writing the name and chemical formula of inorganic compounds, particularly ionic compounds. Okay, for ionic compounds, let's recall that they consist of cations followed by anions. So that's the order. Cation comes first, followed by anions. Another important note, for any ionic compound, we use subscripts. No, upon crisscross method, we have subscripts written after the ion form, and these subscripts are actually the numerical value from each other's ions after you cross it over. And kindly take note that subscripts of 1 is not anymore written. It is not written. Another thing, parenthesis, the use of parenthesis. This is used to enclose polyatomic anion. So to enclose polyatomic anion before writing or prior to writing subscript greater than 1. Okay, greater than 1. And then lastly, there are chemical formulas of ionic compound that needs to be simplified. Okay, so simplified uh, chemical formulas. So kindly take note of that. So if you think a chemical formula could be simplified, then you need to simplify it. That would be the final chemical formula of that particular compound. So we'll have a few exercises first before we proceed to our discussion on acids and covalent compounds. Okay. So the given here are names of ionic compounds, and on the next slide, you are seeing here chemical formulas of ionic compounds. So given the essential notes that I have written on the right side, let's try to write the chemical formula of the following ionic names. Okay, so let's have the first one, calcium oxide. So recall, based on the first note I have provided, in the order, cation comes first, followed by anion. So these are all cations, the one written on the left side. And then this uh, ions on the right side, right portion, are the anions, negatively charged atom. Okay, so let's try to extract the ionic formula of the ions, cation and the anion. So for number 1, calcium's ionic formula, it's 2 plus, Ca2 plus. And then for oxide, as an anion, it carries a negative 2 charge. Okay. And then next, crisscross method to obtain the chemical formula. Meaning, ng crisscross method, you just have to cross over the numerical value of the charges, making them subscripts of the other ion. Okay, so this is a good example of a chemical compound that can be simplified. Try to observe the charges, the numerical value of the charges. They have the same charge, the value of charge. So you can simplify that because they have common denominator. But they have common denominator, and that is 2. So you can simplify that or cancel them out, producing an equivalent of a 1, no? Equivalent 1 na numerical value for its charge. Again, you need to simplify any compound once you write its chemical formula if you think they can be simplified. Okay? So after you cross over the numerical values, writing now the subscript, since the subscript now is equivalent to 1, recall the second important note that we have written on the right side, subscript of 1 is not anymore written. So the final chemical formula for calcium oxide would be CaO2. You can also try to search it, one tab away lang naman no, sa Google Chrome, for the chemical formula of calcium oxide. It's not Ca2O2. This is considered wrong. The simplified or final chemical formula would be CaO. So that's calcium oxide. Sige, let's proceed to the second sample or exercise, calcium oxalate. So calcium again, it's calcium Ca2 plus. Then oxalate, try to check your notes in the list of ions. It's an anion C2O4 with a charge of 2 negative. Again, observe the numerical value of the charges. They have common denominator again, so you can simplify that. Cancel them out. So equivalent to 1 na lang yung numerical value of the charge. So upon crisscross method to obtain the chemical formula, the final chemical formula of the compound calcium oxalate would now be CaC2O4. Okay, so again, subscript of 1 is not anymore written. Next, ferrous oxide. So let me write it. Ferrous, this is an ion of iron with a charge of 2 plus. Okay, recall it's a traditional name of iron 2. That's also equivalent to iron 2. Okay, and then oxide again, it's it's O2 negative. Ayan. So another example of a chemical compound na upon writing its chemical formula, you can simplify it as well. So try to simplify it. So the final chemical formula for ferrous oxide is Fe, then O. Okay. So cross over the numerical value of the charges. So it's just equivalent to 1. So not anymore written, yung subscript of 1. Next, cupric. So this is the ion of copper. So copper is a transition metal. There are two varying charges of copper. We have copper 1 and copper 2. So I will ask question, uh, which ion of copper is this? If it says cupric, is it copper 1 or 2? Okay, so it is copper 2 with a charge of 2 plus. So it's cupric, it's copper 2 plus, then sulfate, it's SO4, 2 negative. So the first four examples, we can simplify. We can simplify the chemical formula. Okay, so simplify them. Common denominator of their numerical value of charges is 2. So the final chemical formula of cupric sulfate is CuSO4. Okay, after crisscross method. Next, magnesium sulfate. So magnesium is Mg2 plus. Then sulfate, it's written above, SO4, 2 negative. Simplify again. Cancel out the opposite charges with the same value. So that's equivalent to 1. Subscript of 1. So not anymore written. It's Mg. Final answer would be MgSO4. Okay, sige. Number 6. Sodium bicarbonate. So you know this. I believe you're familiar with this compound, sodium bicarbonate. Sodium is Na plus, and then bicarbonate, HCO3 negative. Okay, so with regards to the ions, ionic formula, it's your part already to memorize that. What's the ion form of bicarbonate, of sodium, so on and so forth. Okay, sige. Crisscross method, then the final chemical formula, you can obtain it right away. It's NaHCO3. Next, ammonium chloride. So ammonium, it's NH4 plus. Then chloride ion, it's Cl negative. So their numerical value of their charges, it's only 1. So upon crisscross method, you'll only obtain a subscript of 1. So not anymore written yung subscript of 1. So right, the formula ammonium chloride this in this manner, NH4, then Cl. Then lastly, we have potassium permanganate. Potassium, it's K plus. Potassium plus, and then permanganate is MnO4 negative. Okay, so upon crisscross method, crossing over the numerical values of the charges, you can still obtain a subscript of 1. You just have to write it this way. So this would be the final chemical formula of potassium permanganate. Okay, so that's potassium permanganate. So that's how you write the chemical formulas of ionic compounds. So the method is quite simple, crisscross method. That's it. That's the rule to obtain the chemical formula. The challenge lang is the memorization, no, of the ions. That's your part already, which I told you to be familiar with the ions. Okay? Sige. So we'll proceed with the opposite way. So this time, let's try to name the ionic compound given only the chemical formula. So yung opposite way naman. Okay, so you can make use of this information we have written on the right portion of the slide. I told you that all the first atom or ions written on the left side or on the first part of the chemical formula, those are cations. Then the rest, sige, let me underline it first. These underlined elements or atoms, ions, these are cations. So the rest, underlined with, let's say, color green, the rest are anion. So that makes them ionic compound because it consists of cation and then followed by anion. Okay, so let's try to name it. Let's start with the first item. So you have the symbol Ca. Ca, that's for calcium, right? So you extract the ion form of calcium. Diba? Ion form of calcium, it's Ca2 plus. Then CO3, that is for carbonate. You recall the ion form of carbonate, it's 2 negative, as CO3, 2 negative. Okay, so the reason why you are not seeing a subscript of 2 there after crisscross method writing their chemical formula, it has been simplified. So cancel out the numerical value, the same numerical value with opposite charges. That's why you will just obtain a subscript of 1. Okay, so the final name for this chemical compound would be calcium, followed by carbonate. So that's calcium carbonate. Okay, next, mercury. Mercury is a metal. It tends to form cation. Being a transition metal, it can form varying charges. But there are 2 forms of mercury, mercury 1 and mercury 2. So let me ask you, what do you think is this ion form of mercury? Is it mercury 1 or mercury 2? Based on the formula. Try to analyze the formula. Okay, good. That is mercury 1. Observe that it has a subscript of 2 and look at the subscript after chloride. It has a subscript of 2. That comes from the charge of mercury. Okay, so recall. Mercury 1, it's Hg2, 2 plus, and then chloride ion is only negative 1. No, that's why after you cross over the numerical values of the charges, you will obtain this chemical formula Hg2 and then Cl2. Yes, so the name would be mercury 1. So enclosed in a parenthesis the Roman numeral 1, which represents the positive charge, diba, of mercury, and then followed by chloride. Or what's the other name? Diba? This is also known as mercurous. Mercury 1 is also mercurous chloride. Okay, next. Letter K. What is that element? Diba? That is potassium. Okay, so you recall potassium ion is K plus. Then NO3, that's the ion form of nitrate. Okay, so upon crisscross method, you will obtain this compound, KNO3, or also known as potassium nitrate. Okay, next, sodium bicarbonate. So sodium, that is Na plus, then bicarbonate, HCO3 negative. Okay, so that's the name, sodium bicarbonate. Okay, next, Mg for magnesium. Di ba magnesium is Mg2 plus. So this subscript 2 here, that comes from the numerical value of the charge ng magnesium. And then hydroxide, it's OH negative. Okay, so you will produce this compound magnesium hydroxide. Okay, next. Okay, please try to familiarize this compound number 6 and number 7. You will be exposed with these chemicals in your laboratory. You will be performing different qualitative analysis in your laboratory experiment. So you will also encounter these chemicals. Okay, so please observe the difference. Both carries potassium ion, but they have potassium ion, and then the chromate here is for number 6. Okay, yung CrO4, CrO4, 2 negative, that's chromate. It's different from dichromate. Okay, so this is potassium chromate. And then for number 7, yung Cr2O7, 2 negative, that's dichromate. Okay, excuse me, potassium dichromate. In during your laboratory experiment, kindly distinguish also, no, be able to distinguish which of which is the chromate and dichromate. You will easily identify that based on their color. Okay, so you will not be confused if you are, let's say, doing experiments with these two forms of ions, the chromate and dichromate. Just take note that the chromate is color yellow and dichromate is color orange. Okay, so that's the characteristic color of the ions, chromate versus dichromate. Okay, so kindly take note also of the ion form. I believe you are somehow familiar already with their ions. Diba? I told you to memorize the ions, the ionic formulas. Okay, then last, Sn. Sn is 14. Okay, so Sn2 plus. That is 2 plus based on the compound, chemical formula of the compound. Look at the subscript after fluoride. Diba? You are seeing a subscript of 2 that comes from the numerical value of the charge ng tin. Then fluoride, diba, is F negative 1. Okay, so that's tin 2 fluoride, or also known as stannous fluoride. Right? So that's how you write the name of ionic compound. So somehow, if you know already how to write chemical formula, it will follow na you will also easily name any ionic compound. Okay, so your foundation really to answer any questions about ionic compound, naming or writing formula of ionic compound is to first memorize the ions. You have to, okay, you have to memorize the ions. That's why in the first day of class, diba, I already told you to memorize the list of ions. Okay, so for this part, I'll just give this as your, let's say, assignment for during your independent study time so that you have, uh, you can check, no, or have a comprehension check during your study time, independent study. Okay, to practice also how to name and then write chemical formula of ionic compounds. Okay, second. Next, after ionic compounds, let's proceed to acids. Okay, so before we write names or write the formula of any acids, let's first define what is an acid. An acid is any substance whose molecules yield hydrogen ions when dissolved in water. So that's a characteristic of acid. Just take note. They are said to be proton donor. Okay, so based on the definition, hydrogen ions, it is being yielded, it is being released when dissolved in water. The hydrogen ion, we are also referring here with protons. Okay, so when you heard about H plus or hydrogen ions, that is also referred to as protons. And protons again, it's H plus. Now let's try to find out why. Why hydrogen ions are also referred to as protons. Okay, let's go back to the uh, uh, information about the atomic structure of hydrogen. Okay, recall that hydrogen has three isotopes. Diba I told you that hydrogen atom has three isotopes. My question, which among the isotopes is the most stable? The most stable, most abundant, the most common, the most stable, most abundant, and most common isotope of hydrogen. Uh, you recall protium? You remember protium? I introduced this to you. It's one of the isotope of hydrogen. Okay, so being an isotope of hydrogen, of course, it would have atomic number of 1. Okay, let's just recall first the uh, kumbaga, characteristic of this atomic structure of hydrogen, specifically for protium. Okay, so let's start with atomic number. Yes, it has atomic number of 1, being the first element in the periodic table. So having that atomic number of 1, it also means that it has a proton number of 1. Diba? Tama? Recall, atomic number is just equivalent to proton number. Okay? Now, since the given element is neutral, no charge, meaning to say, proton number is also equivalent to electron number. Diba? That's our consideration if the atom is neutral. So meaning to say, the electron number is also 1. Now, try to check your periodic table of elements. Di ba yung hydrogen atom dyan, it has an atomic mass of 1. Okay? So given this information that it has an atomic mass of 1, we can compute the neutron number. Because neutron number is just atomic mass minus the atomic number or the proton number. So you can just substitute the values. 1 minus 1. Okay, atomic mass minus the proton number or the atomic number. So that is equivalent to 0. So meaning to say, when we draw the atomic structure of hydrogen, so let's say this is the nucleus of hydrogen. What surrounds the nucleus, diba, are electrons. Where can we find electrons? Atomic orbitals, diba? When we define atomic orbitals, the region in space around the nucleus where there is a highest probability of finding an electron. So for hydrogen, since it is found in period 1, look at your periodic table, nasa sa period 1, so it has only one shell. Okay, that's the highest energy level for the atom hydrogen. So one shell. That's why I am only presenting here one shell that surrounds the nucleus of the hydrogen. Now, given this information, uh, for hydrogen atom, it has only one electron. So that's one electron, which I have presented in the illustration. Another, for its proton, it has also one proton. The protons are found, diba, inside the nucleus. Neutron. Neutron are found in the nucleus as well. However, in the case of hydrogen atom, particularly for the isotope protium, it has no neutron. So that's distinct about hydrogen atom. It has no neutron. Now, we are talking here about the atomic structure of hydrogen. No charge pa. Hydrogen atom, no charge. Now, let's say this hydrogen atom during chemical reaction, it forms ion, meaning it forms hydrogen ion. Look at the charge of hydrogen ion, positive charge. So meaning to say, if it carries positive charge forming cation, during chemical reaction, it loses. Tama? It loses electron. Diba? That's our consideration if the atom forms cation. Meaning to say, it loses electrons. So in this case, when it forms H plus hydrogen ion during chemical reaction, it loses one electron. Okay? So if it loses its only one electron, my question, what remains or retains in the atomic structure of hydrogen? What retains? Ano na lang yung natira? Sige, you'll answer. Ano yung natira based sa illustration? Kung dinonate niya yung electron, ano na lang yung natira? Yes. Only proton retains in the atomic structure. That is why I told you that hydrogen ion is also known as proton. Okay, so when it forms hydrogen ion, it is also equivalent to proton based on its atomic structure. Since it loses electron, then what remains in its atomic structure is only proton. Okay, so any acid contains proton and they are able to donate or release proton when dissolved in water or during chemical reaction. Acid will always donate. Never will happen that they will accept proton. Okay, since what they contain is proton, then they are willing to donate that. Okay, so they are proton donor. Now, acids are derived from non-metals. Okay, now in the periodic table of elements, photographic memory, non-metals are found on the right or left of the periodic table. Right or left in the periodic table? Are you sure? Non-metals. Non-metals like chlorine, bromine, iodine, oxygen, nitrogen. Yes. Diba? They are found here on the upper right portion of the periodic table. Now, so that includes chlorine, yun, I've mentioned earlier, chlorine, bromine, iodine, fluorine, nitrogen, oxygen, phosphorus, sulfur. Diba? They are found here. So those are examples of nonmetals. So acids are actually derived from nonmetals because nonmetals are the ones that forms anions. Okay? So we can derive acids out of anions. Diba? Anions are negatively charged atom. Okay? Now, based on our discussion last meeting, anions name differ. We have anions ends in "ide", ends in "ate", or ends in "ite". You remember that, right? For example, bromide, chlorate, chlorite. Okay, so they differ in their names. Okay, so we can actually derive acids out of these anions. So how do we name? How do we name acids out of these anions? So first, we have acids that we can derive from anions ending in IDE. Diba? Example, bromide, Br negative. Diba? This is an anion ending in IDE. What else? Chloride, iodide, fluoride, cyanide. Diba? These are examples, again, of anions ending in IDE. Now, how do we name acids that we can derive from these anions? Okay. If it ends with IDE, listen, you have to change that, replace the ending IDE to ic acid and use prefix hydro. Okay? Hydro. So when you say prefix, kapag prefix in English grammarly, it is added on the first part of the word. Okay? Yung ic acid, this will be suffix. Okay? Kasi we have to change the IDE. That is the suffix, no? Ending. Ending name of the anions. Like bromide, chloride, fluoride, cyanide. So you change the IDE ending into suffix ic acid, and then for its prefix, use hydro. So for example, let's extract one. Chloride. Diba? Chloride is, okay, it has an IDE ending. So let's say the question is, what acid we can derive out of chloride ion? So the name of that acid would be hydrochloric acid. Look at what happened. We changed the ending IDE to ic acid. And we added a prefix, hydro. Prefix again is added to the first part of the word. Okay. Now, next question, how do you write the formula of hydrochloric acid? Remember, any acids are said to be proton donor, or they yield or release hydrogen ion when dissolved in water. What you will do is simply add H plus with that chloride ion. Then do the crisscross method. You follow? Crisscross method that we did earlier to obtain chemical formula of ionic compounds. So you do the same here. The hydrogen ion will act as the cation, and of course, the anion here would be the chloride. So crisscross method, the final chemical formula would be HCl. So that's how you derive acid out of anions ending in IDE. Sige, let's have more example. Let's have bromide. Di ba? Bromide, it's ending also. with IDE. So the question, let's say, name the acid that you can derive from bromide ion. So you follow the rule. Change the IDE ending to ic acid, then add prefix hydro. So that becomes hydrobromic acid. Okay, look at what happens to IDE replaced with ic acid. Then we add the prefix hydro. Sige, your turn. What do you think would be the chemical formula of hydrobromic acid? Sige, you write in that, make use of the chat box. Okay, very good. The chemical formula is HBr. Okay, so H and then the elemental symbol of bromide. So that's hydrobromic acid. Okay, last example. Let's say the given is cyanide. This one. Sige, your turn. What would be the name of the acid derived from cyanide ion? Okay. Okay, good. So since it ends also with IDE, you change the IDE ending to ic acid. So that's cyanic acid. And do not forget the prefix hydro. What would be the formula of hydrocyanic acid? So you have H plus, then Cn negative, you cross it over. The subscripts are only one, so that would be HCN only. Okay, so that's the first type of acids. Acids that we can derive from anions ending in IDE. Sige, let's proceed. Excuse me. Okay, the second type of acids are those derived from anions ending in ate and ite. Remember that majority of the ions, they are named with these suffixes. They have ate and ite suffixes. Okay, what you will do in order to derive the name of the acids out of these anions, if it is ending in ate, example, chlorate, what you will do to derive the acid name, change the ate ending to ic acid. That's it. No more prefix added. The hydro prefix is only applicable for those anion ending in IDE. Okay? So for example, chlorate. Diba chlorate is ClO3 negative. So if the question is, what's the name of the acid we can derive from chlorate ion? So the answer would be chloric acid. That's it. You just have to change the ate ending to ic acid. Now, your turn. What would be the chemical formula of chloric acid? You just have to add H plus. This will serve as the cation, then followed by an ion. Yes? So that would be, okay, HClO3. That's chloric acid. Okay? Next. What if the anion ends with ite? Example. What's the ite form of chlorate? Diba? It's chlorite. Okay, so this time the anion name ends with ite. So that's ClO2, right? Diba? Pag chlorite, one less oxygen from its chlorate form. So ClO2 negative is chlorite. So if it ends with chlorite, sorry. If it ends with ite, rather, you just have to replace the ite ending to ous acid. That's it. Okay. So, for example, from chlorite, the acid name we can derive or associated with chlorite anion would be chlorous acid. Okay? Sige. You try to write the chemical formula of chlorous acid. Make use of the chat box. So that would be H, then ClO2. Okay, good. That's it. So that would be the rule in naming acids. If it ends with 8, change that to ic acid. If it ends with ite, change the ite ending to ous acid. Okay? Sige, another example, let's say uh okay, this is the given. I will not name it. Okay, so I believe you are familiar with this anion. It is an anion. So my question is, what would be the name of the acid? No, no, no. The acid already. What would be the name of the acid? Okay. Okay, since correct, this is iodate. So the name of the acid would be iodic acid. Now, you write the chemical formula. What's the chemical formula of the acid you can derive from iodate? Okay, good. So that would be HiO3. That's it. This is iodic acid. Now, in the case of sulfate, diba, that is also an anion. Let me erase this part, ha. Ay, sorry. In the case of sulfate, diba, sulfate is SO4, 2 negative. So this is sulfate. So if you will be asked for the name of the acid we can derive from sulfate, it's not sulfic acid, ha. There's no such term as sulfic acid. The appropriate name of the acid is sulfuric acid. It still ends with ic acid. So it's sulfuric acid. Okay, so that's the equivalent acid name from derived from sulfate. And sige, what would be the chemical formula? Sige, your turn. What's the chemical formula of sulfuric acid? After crisscross method, okay, yes. So that is H2SO4. Okay, you cross over the numerical values, okay, of the charges. So that would be H2SO4. So that's the formula of sulfuric acid. What about, let's say, so last example. Let's say the ite form of sulfate. The ite form of sulfate is SO3, 2 negative. So this is sulfite. One less oxygen from sulfate. Sige, go. What would be the name of the acid? Okay. The name of the acid we can derive out of this would be sulfurous acid. Okay. And then the formula would be H2SO3. Okay. So that's it. Those are the acids that we can derive from an ion. So recalling all of them, if it ends with IDE, listen, if it ends with IDE, you should make use of the prefix hydro. Then change the ending IDE to ic acid. Ayan. Change the IDE ending to ic acid. Use the prefix hydro. Okay? So when you heard about hydrofluoric acid, hydroiodic acid, you have to keep in mind that these acids are derived from anions ending in "ide." Okay? But if the name of the acid only ends with an "ic" acid, no prefix hydro, then higher chances that acid is derived from an anion ending in ate. Okay? Then if it ends with an ite, simply change the ite ending to ous acid. Okay, so these are other examples. So I believe you understand it already. For perchlorate, this is another example. It ends with an 8. So when you derive its corresponding acid name, you just change the 8 to ic acid. So perchloric acid na. And then for hypochlorite, its equivalent acid name would be hypochlorous acid. Okay? So that's it. Sige. We're done answering letter A, C, D. So based on our previous na slides I have presented, diba, this is hydrocyanic acid. Okay, kasi these parts underlined for letter A, that ends with IDE, that is cyanide. So it ends with IDE, so its name should end with ic acid and must have prefix hydro. Okay? We're also done with letter C and D. Letter C, this is sulfuric acid, diba? And this is sulfurous acid. Okay, I let you answer letter B. Make use of the chat box. What do you think would be the acid name of letter B? NO3, that is nitrate, right? Sige, it ends with 8. So what would be the acid name? Excuse me. Okay. So the acid name would be nitric acid. Okay, so your foundation naman here for to name or write chemical formula of acids is you have to familiarization with the anion, since acids are derived from anions. So you have no choice but to really memorize them. Okay, for you to answer this type of questions. Okay, sige. For number 2, this time, let's try to write the formula, no, based on the given names. Look at letter A. Observe that it has a prefix hydro, meaning to say, this is an acid derived from an ion ending in "ide." Okay? So, probably, this root name bromine, is from the anion bromide. Yes. So, when you extract its formula, you simply add H plus here, then cross over the numerical value of the charges. And then, yes, correct. The final answer for hydrobromic acid's formula, it's HBr. Next, for letter B, there is no hydro na prefix. You will observe that it only makes use of the suffix ic acid. So meaning to say this comes from the anion ending in 8, which is carbonate. Okay? So you have to recall, what's the anion form of carbonate? Carbonate is CO3, 2 negative. So you add H plus. Then crisscross method. Yes. Okay. So the correct formula for carbonic acid would be H2, then CO3. Excuse me. Okay. Question. Any question before we proceed to the next slide? This would be the last topic for today. Okay. We still have more to discuss next 2 weeks. Yes, so wala na question. Sige, I will proceed to the last compounds that we will be naming and writing formula. So these are covalent compounds. Now, when I say covalent compounds, they consist of nonmetals bonded to another nonmetal. So in the compound, when you try to examine the structure of the compound, it is said to be covalent if it consists only of nonmetals. Okay, two or more different nonmetals. That's covalent compound. So what happens here is only sharing of electrons. Earlier, regarding ionic compounds, more on it involves transfer of electrons. So that's a keyword. Again, have for ionic compounds, there is transfer of electrons. Transfer because one will lose electron, the other atom will accept electron. Diba? That's the components of ionic compound. It has metal and non-metal. The metal will lose electron, non-metal will accept electron or gain electron. So transfer of electrons happens. If covalent compound, sharing of electrons only. Okay? So specifically, we will be naming binary covalent compounds, meaning to say, the compound consists only of two elements, two kinds of elements. Okay, so how do we name binary covalent compounds? So we have to take note this four considerations. So letter A, it says here that the name of the element farthest to the left in the periodic table, they are usually written first, except for the compound containing oxygen. Oxygen atom is always written last. Okay, what does it mean? Let's say, for example, I'll give you a sample analogy to better understand letter A. Let's go to the periodic table. Let me erase this writings. Okay, let's say, for example, uh, you have the elements, let's say, oxygen. Sorry. Ayan, oxygen and nitrogen. Okay. Uh, then you are asked for the compound that you can derive out of these two non-metals. When they are combined, what would be the covalent compound that we can derive? Now, looking at the periodic table, nitrogen and then oxygen, they are found on the same period. Diba? Same horizontal row. Okay? Based on letter A, consideration letter A, the element on the left part, okay, found on the left side in the periodic table, they are written first. So meaning to say, the compound that you will derive here would be NO. Okay, we will just name it later. Okay, so this will be the order. It should be NO, not ON. Okay, I hope you got my point sa letter A, consideration. That's the point of consideration letter A. The name of the element or the element on the left, farthest to the left in the periodic table, they are written first. Okay, so let's have another example to understand it well. Sige. Let's say chlorine and sulfur. So let's say chlorine and sulfur. Then you are asked what compound, covalent compound, you can derive out of these two nonmetals. So you have to check, no? Where is chlorine in the periodic table, where it resides? Is it on the left side or on the right side? So looking at the periodic table, sulfur is the one on the left side, right? So sulfur comes first, followed by chlorine. So that would be the compound that we can obtain out of these two nonmetals. Okay? So that's consideration letter A. So for oxygen, any covalent compound combined with oxygen, oxygen is always written last. So that's the exception naman for oxygen. Next, letter B. If the elements are on the same period, group rather. If the elements are in the same group in the periodic table, the lower one is named first. When you say same group, we are talking about the vertical, right? The vertical grouping, the vertical row. Sige, going back to the periodic table. Let me change the color. Let's say, sige, I'll give example of elements on the same group. Let's say sulfur and oxygen. Now, try to look at, they are on the same group, right? Same vertical row. So you will be asked, for instance, as oxygen and sulfur, what covalent compound we can produce out of these two nonmetals combined? So it says there, letter B, consideration, the element in the lower part is written first. So that would be sulfur will comes first, followed by oxygen. Okay, so that would be the compound, okay, that you will derived out of that uh, given combination of nonmetals. Okay, what's the rationale behind why leftmost elements in the periodic table and the lower ones are written first in the formula of any covalent compound? It is because they are least electronegative. Least electronegative atom are written first. Okay? They are written first in writing covalent compound. Kasi later on, when we draw Lewis structure of these compounds, you will get to understand that the first element with least electronegativity, they should be surrounded with electron-rich atom, just like oxygen. Okay, that's why oxygen lagi always written last kasi it's a surrounding atom. It's electron-rich, so never will happen that it is written first because it is electron-rich. Remember, the least electronegative atom are the ones should be written first. Okay, so that's the reason lang why we have this consideration. This will help you be guided what would be the order, which comes first and then which comes last in writing the chemical formula. Next, for letter C, the name of the second element is given an "ide" ending. So let's say, for example, the given is N followed by O. Okay. When you name this elements in the covalent compound, the second element should end with an "ide" ending, the name. Instead of oxygen, this is now oxide because it's the second element in this compound. Whereas the first element, you just have to name it based on its name in the periodic table. What's its non-metal name? N is nitrogen, right? Okay. So the second element should be given with "ide" ending. Okay. And then last, Greek prefixes are used to indicate the numbers of atoms of each element. What are examples of Greek prefixes? Di, tri, tetra, yan, penta, hexa, so on and so forth. Okay, so let's say for example, in this given compound NO, I will write a subscript of 2 after oxide. Okay, so this tells us that in this covalent compound, the number of oxygen in this given compound, there are 2. There are 2 oxygen. So to indicate that there are 2 oxygen atoms in this covalent compound, we have to use the prefix di. So before writing oxide as the name of the second element, you have to use prefix di. That is to indicate again that there are 2 two oxygen atoms in this compound. So the final name would be nitrogen dioxide. So what are other Greek prefixes? We have the following. Okay, so just take note of these Greek prefixes. This is somehow easy to familiarize. Diba? Di means 2, tri, 4, 3, tetra 4, penta 5, hexa 6, hepta 7, so on and so forth. Mono is 1. Okay, now before we proceed to more examples in naming binary covalent compounds, please take note of this very important note. No, the prefix mono, this is never used in the first element. That's why when I wrote here the final name of the compound nitrogen dioxide, I did not write prefix mono for nitrogen because the prefix mono is not used, where is it? Ayan, not used in the first element. It's only used for the second element. Okay, so take note of that. That's one important note. And then next, whenever the prefix ends with A or O. So these are prefixes on the left side. The table on the left sides are prefixes. When the prefix ends in A or O, example, well, these are prefixes ends in A. For mono, it ends with O. And then let's say the name of the second element begins with a vowel. Example, oxide. So let's say mono, and then the name of the second element is oxide. Now, if that happens, you need to drop or omit the ending A or O from that prefix. So for example, instead of saying mono-oxide, you have to drop the ending O from mono to make it monoxide. Okay, monoxide. That's the correct naming of the second, or yeah, the second element in the covalent compound or binary covalent compound. So yeah, let's have more example for you to better understand. Now, try to observe this compound, Cl2O. So you are seeing two atoms of chlorine. That's why it is named as dichlorine. And then look at the second name. Instead of oxygen, it ends with "ide." Diba? That's consideration letter C. I have presented that earlier. The second element should ends with IDE. So it ends with "ide." That's why it is now named as oxide. Now there is only one atom of oxygen in the compound Cl2O. So we have to use the prefix mono. That is to indicate that there's only one oxygen in this atom. Now, try to look at the final name. Instead of saying mono, then oxide, the letter O from the prefix mono has been omitted. Okay, so the correct name would be monoxide. Dichlorine monoxide. Sige, let's have another example. Yung second one. Look at the compound, N2O4. So there are two nitrogen. That's why it is named as dinitrogen. Then the second element, it ends with "ide." So it is now oxide. How many oxide? 4. So we use the prefix tetra. So instead of saying tetra, sorry, it's not clear. Okay, tetra, ayan, tetra oxide. Look at what happened to the name. The letter A from tetra has been omitted. Okay, so making it tetroxide. So please take note of this important note. Whenever you encounter a prefix ending in A or O, and then the following name of the second element starts with a vowel, and you have to drop the letters A or O from that prefix. Okay, then we have NF3. This is nitrogen. Do not use mono. No, do not use mono sa first element. So nitrogen only, and then followed by trifluoride. And then phosphorus, there are four, so tetra phosphorus. And then there are 10 sulfur. So that is named already as sulfide. Second element should end with IDE. So deca sulfide. So that's how you name binary covalent compound. You just have to count, no? Count the number of atoms in that binary compound, and then just take note that the second element is named with IDE ending. Sige, your turn. Let's try to name the first three example for test one. What do you think would be the name of letter A? Covalent compound letter A. Go. Mhm. This is sulfur. Okay, dioxide. And then we have phosphorus, penta. Okay, penta, chloride. And then this one, there are two nitrogen, so nitrogen. And then three oxide, so trioxide. Okay, sige, last. Last slide naman. Sige, try to write the chemical formula. It's very easy if it's binary, no? Binary covalent compound. Because you just have to count it. Count and then write the elemental symbol. Okay, yes. Silicon, it's only one. Then 4 bromide. So 4 bromide. And then disulfur dichloride. So 2 sulfur. And then 2 chloride. Okay, that's it. You don't have to memorize. No? You don't have to memorize list of ions here. More on the familiarization of the elemental symbol. You have to know the symbol of sulfur, silicon, bromine, chlorine, nitrogen, etc. Okay, so that's your foundation naman in uh, learning how to name and write formula for binary covalent compounds. Okay, now during assessments, let me give you sample na mga questions how I usually give my questions during online quizzes relative to this topic. Okay, I will not ask you questions like name this compound. Okay, so hindi po ganito yung pag-give ko ng mga questions. Expect that there will be a sort of kumbaga challenge or twist sa mga questions. Let's say for example, I will be asking uh, name the binary covalent compound that you can obtain with the given elements or atoms. Okay, so this will be the question. That's example question number 1. And then the instruction would be name. You give the name of the covalent compound you can obtain given these atoms. So you have to recall the considerations. How do we write formula of covalent compound? So you have to recall which of which comes first and the last element. So in your periodic table, sulfur is found on the left side of chlorine. So sulfur comes first, followed by chlorine. Okay? Or let's say I will give here a numerical value. 2 atoms of sulfur. So you have to write S2Cl. Okay, so that's the formula. The name would be disulfur. So after you are able to obtain the formula, you can now name it. No, disulfur monochloride. Diba, mono is used in the second element. Okay. Another example for acids, you will be asked, sige, number 2, what is the name of the acid you can derive out of this anion? So you have to know, what is this anion? Diba, this anion is borate. So it ends with 8. What do you think would be the name of the acid you can derive out of borate? Sige, you can make use of the chat box. What will you change? What will happen to the 8 ending? So that would become boric. Okay, boric acid. So you expect this kind of question during assessment. It's not name. I will give the formula easily. I will give the formula HbO3. Okay, name this compound. No, you will be the one to obtain what compound you can derive out of that given ion or element. So boric acid, yes, boric acid is H3BO3. Diba, you just have to add H plus, then cross over the numerical values. Okay. And then last, for ionic compounds, let's say the given is chlorine atom and magnesium. So if you try to analyze the given elements, the given atom, di ba chlorine is non-metal? How will you know it's non-metal? A non-metal. Di ba it is found on the upper right portion of the periodic table? Magnesium, it's metal. So based on this given atoms of the elements, and we could tell the compound that you can derive out of this would be ionic compound because you have a metal and a non-metal. So my question, what would be the ionic compound you can derive out of this? Try to name it. So you have to recall our discussion that any ionic compound starts with a cation followed by an ion. Okay. Class, between the two, which do you think will form cation? Which has cation form? Sige, type in. Is it chlorine or magnesium? Okay, it's magnesium. Or you recall the cation form of magnesium. Di ba magnesium is M, I will write it here, Mg2 plus. Okay? That's the order, right? Magnesium comes first, followed by, cation. Cation comes first, followed by an ion. We discussed that earlier. Okay? Then non-metal will follow, which is the anion. Anion form of chlorine is chloride. Then you can now obtain what would be the compound. Sige, crisscross. You tell me what's the name. Name, not the formula. Name the compound. Okay, that's it. You see, you can answer any question based on the discussion we had. Okay, so magnesium chloride. Okay, and then the formula would be Mg2Cl. Okay? Sorry. Sorry. It's MgCl2. Okay? So in MgCl2, that's the final formula, chemical formula of magnesium chloride. So expect these kinds of question, ha? I will not give you the names. Nga, example, give the chemical formula of magnesium chloride. No. Okay, so expect this kind of question during online assessment. So next week, we will have series of, I will end first the recording. Okay, we'll have